Hi, I am Aleph. Those of you who have been following my channel know that I like a good controversial argument. Among mathematicians, saying that the real numbers are not larger than the naturals is probably the most controversial thing you could ever say. However, I think a good argument could be made that the consensus view is wrong. I want you to think of mathematical objects as informational objects. To illustrate this, here is Richard Harvey explaining why transferring or storing the number pi does not transfer or store an infinite amount of information.
So if I was going to code a string of digits like this, then you, knowing as you do now about Shannon information, you'd say, well, I'll work out how much information is required to code that sequence of 10 digits. And you'd say to me, well, 10 isn't enough. I must know the probabilities of these digits. So I'll tell you they're equiprobable. So you'd say, oh, yes, 1 over 10, log 2, 1 over 10, minus that, 3.3 bits per symbol. So 10 symbols, 33 bits. No worries with that. That's an exact follow-on from my previous remarks, I think. We're all cushy with that. And so 100 symbols would be 10 times as large, 330 bits. 1,000 symbols would be 3,300 bits. 1,000,000 symbols would be, well, just to be technically right, it would be approximately a megabit. For those of you who don't know, a megabit in the digital world isn't a million, it's 1,024 times 1,024, but let's leave that to one side, okay? So it's roughly 3.3 megabits, all well and good. But I'm sure intelligent people in this audience are already bristling at this thought, and so am I, really. There's a problem here, and the problem is that those are the first 10 digits of pi, and it is true that the digits of pi are roughly equally distributed, but I think the challenge of this really is, are you really saying, Richard, that it takes an infinite amount of information to transmit pi? Because if so, the internet's going to break, because I've just transmitted it to you. I just said pi, and you knew roughly what I meant. I mean, you might have forgotten your high school mathematics, but you were vaguely aware of the concept called pi, I should think, and Kolmogorov information. It's a very beautiful idea. And so the idea is that the information or content of an object is not the object, but it's the length of the shortest program that can compute the object. Neat. Okay, very nice idea. So pi, well, this was the shortest program I could find for computing pi, 160 characters. So if it has 160 characters, 8 bits a character, let's say, that's 1,280 bits. So I'm confident that the information in pi is less than 1,280 bits. Now, it doesn't tell me how to find this program. So if I could find a shorter program, then I could state confidently that pi contains less information than that.
What I am saying is that all mathematical objects are informational objects. Strings of ones and zeros. Or even computer programs. If you doubt this, try to come up with an example of an existing mathematical object that is not encoded in a finite number of bits. If you intend to communicate or store any mathematical concept, you are bound by the laws of information theory, and therefore obliged to see mathematical objects as informational objects. All the allegedly infinite entities in mathematics can be understood in terms of information, of computer programs that can be encoded in finite numbers of bits. Take the axiom of infinity, which is used to define the natural numbers, for example. And here I am assuming you are familiar with the language of predicate logic and set theory, so you can read this formula. Just as with the number pi, whenever the concept of the natural numbers is stored or transmitted, it is not an infinite amount of information. We are conveying the information contained in the algorithm that defines the natural numbers. For example, the following Python program. Note two things. First, this program does not halt. Second, how this program is equivalent to the axiom of infinity. Empty set is in x is here. When y equals 0, the condition y in x is met because of this variable assignment. The universal quantifier that binds y is the while true loop. Y union with set containing y is equivalent to y equals y plus 1. And when we say that as a member of x, we just mean x dot add y. And the existential quantifier that binds x, I would argue, is the return x statement. However, as I mentioned, this program does not halt, and therefore the return statement never actualizes, and therefore saying that X exists is an internal contradiction. You might as well use the following contradictory formula as your axiom. Now let me talk about the implications of this view for Cantor's diagonal, the argument that is used to allegedly prove that the real numbers are greater than the natural ones. The argument goes like this. Suppose we have any list of the real numbers. We can define a real number that is not in it by going down the diagonal such that we change the first number's first decimal place and the second number second decimal place and so on. Therefore, one cannot have a complete list of the reals. Notice the use of these ... symbol. Everyone knows what it means, but no one ever bothers to formalize exactly what ... means. If we accept all mathematical objects are informational objects, then we can see clearly that this ... is an implicit computer program that lists all the real numbers. Since the program that generates the real numbers does not halt, then this program that lists the real numbers does not halt either. It therefore does not have a final output. Notice how the Cantorian diagonalization is itself a computer program that takes as an input the final output of the listing program and returns a number not in the list. But if the listing program does not halt, then the Cantorian diagonalization does not halt either, and therefore it has no final output, and therefore there is no number not in the list after all, because indeed there cannot be a list of all the reals. Because a list of the reals is a program that never halts. If I am right, then speaking about the cardinalities of infinite sets is like speaking about the properties of the final output of programs that do not halt. Since programs that do not halt do not have a final output, this is a self-contradiction. Equivalent to speaking about 0 divided by 0. I hope you enjoyed the video. Remember to like, share and subscribe, and donate crypto so I can keep making videos like this.